glad to have wonderful speakers today to talk about big data. What is big data? So you probably all heard of this joke. Big data is like teenage sex. Everybody talks about it. Everybody thinks they are doing it, but nobody knows what it is. Nobody knows what to do. So hopefully after our session today, we will get kind of an idea of what big data is and how important it is in our daily life. So we'll have 4 speakers today. So first is Mr. Yugang. So he's currently the principal scientist at Overstock. Before that, he was a lead software engineer. He received his bachelor's degree from Zhejiang University and master's degree from Peking University, both in computing science. So he's going to talk about big data, big challenges, big opportunities and tools. Okay.
Thank you. Thank you for coming. Hopefully, I'll let you guys know a little bit about big data itself. So as Jeremy already introduced, I'm a principal scientist at Overstock. Basically, I'm doing lots of research work in that area. So a couple years ago, I built a recommendation system for Overstock. So I'll talk about that one a little bit more when we talk about business opportunities. Okay. So big data. What is big data? So we all know there are enormous data coming in these days, and we're getting lots of them. So the first one is the volume, so amount of data. We all understand what that is, right? And the velocity, basically how fast we're getting those kinds of data. So based on the Cisco data, they're talking about by next year, we're going to get just the IP traffic alone. We're going to have 1.3 petabyte, which is 1,000 billion of terabytes. So think about that. And variety. We're having lots of different kinds of data. So data from different sources, different types, unstructured data, semi-structured data, things like that. So when we talk about big data, typically we talk about these 3 V's. But recently they add a couple other V's as well. Not necessarily everyone agree on, okay? But I'm going to put it here as well. Veracity, that's another thing they're talking about. So it's mainly about accuracy. Okay. And another one is value. So how much value we can get out of it. Someone even putting visualization as another key. So it's kind of interesting. Okay. So what's the big challenge? Since we have lots of data, and so because it's too big to put in main memory and even one machine. So the existing things cannot no longer work anymore. Existing machine learning algorithms no longer working anymore. So that's why we need experts like Jeff to create more algorithms to make it work in a distributed environment. So same thing, MPP architecture no longer very effective. So here's the opportunities. This is from Wikibon. And 2013, we're talking about big data market. It's about 18 billion. Okay, but 2014, it's a 28 billion. So think about it. It's so growing so fast and so big. And by 2017, it's going to be 50 billion. So it's a huge market. just by type. Big data revenue by type. Like services got like 40% share in 2013, things like that. That's a rough share, and I would imagine it will change. And this one is the revenue by subtype. Professional services in 2013 is about 6 billion market. So it's huge. Before that, probably I would like to mention another thing as well. Like last year alone, the new money going to that industry, analytics industry, it's $2 billion. Just the new money from venture capital. And there's a couple local companies as well. Like Domo. Domo is the BI company. They are getting 125 million only last year. Okay, total, I think they got 250 million. And yeah, the market is huge. And Cloudera is basically doing a support for Hadoop distribution. Now their valuation is about 2 billion. They only provide support, things like that, because Hadoop is an open source project. And there's 3 big companies behind it. Cloudera is one of them, NetApp, Hortonworks. They all get lots of money, so think about that. And business opportunities. So basically I just put it some use cases. There are a lot more than these, but so like spam, junk email detection, fraud detection, intrusion detection. We all know that, right? We have been doing that for quite a while. And friends recommendation from LinkedIn, Facebook, and trending hashtags, we all know. Even the Voice, right? You guys know Voice? It's a TV series, TV show. Okay? They're using a hashtag to predict which one should join the family. News clustering. Google, Yahoo, they all do that. So basically, for the same news, we don't want to show 10 lines just for that same news, right? So what they do is they cluster the news and only present one to you so that you know, hey, that's the news. Then once you click it, it will show you all the news from different sources. Like one from CNBC, CNN, or something like that, right? But it's talking about the same topic. Okay, anomaly detection is kind of similar. I mean, it's the fraud detection, stuff like that. But it's a broader, so you can apply it to anywhere, any industry. Okay, and autocomplete, keywords relevancy, it's done by everyone almost. Google, Yahoo. When you're typing a search term, then Google, Yahoo, even Overstock, they're trying to predict what you are truly looking for, then present options to you. Then you just need to pick, hey, here's what I want, right? That's a search term I want to search. And data validation services. That's kind of a new category in some degree because we're getting lots of data. So we need to make sure the data we're getting are correct. For example, website typically have lots of third-party JavaScript inside. Each one is tracking different kinds of information. Like some of them for ads, analytics. Some of them are for different services. So when you make sure, sometimes we want to make sure the report they are generating are consistent. So I know there's the local company working on that, trying to provide service to those websites so that they know which data they can trust. And here's the business opportunities in retail. So because Overstock is the retail, online retailer, so I just put in a couple things in here just so I know we can come up a lot of stuff from healthcare industry, things like that, but yeah, here's what I'm familiar with. Okay. Forecasting sales, email targeting, geo-targeting, retargeting customers via ads, coupons, things like that, and personalized content. That one can be used anywhere as well. So we can personalize search result, we can personalize coupon, so we can give you a different coupon based on what we know about you. And recommendation system, yeah, that's what I built. So you guys probably already know from Amazon Overstock. So when you look at a product, it will give you a recommendation, say, hey, people who view these also view that. People who purchase that also purchase that. So give you some opportunities to look at those new products you may not be aware of. And product bundling capability. So when you purchase something, you might want to purchase a directory as well. And customer segmentation. So basically we group customers into different categories so that we can target those different segments differently, even in email. So price adjustment, replenishment, that's kind of interesting. So this one basically, if you buy a repeatable items, we can reorder for you. And technical opportunities. So probably lots of people already know. Last year it's kind of like the year of analytics. That's why they're getting huge amount of money from these. Okay, real-time analytics, and it's kind of in the same category, business intelligence, data visualization stuff. It's been very, very hot. So value-added services. So basically, it's kind of additional services than the common one, like analytics stuff. You can build other stuff to add value to a customer. Professional services. Basically, you can provide training, those kind of support, like Cordera, like Meta, stuff like that. So it's huge. And I know there are lots of companies behind all those open source projects. The one I mentioned is behind Hadoop distribution. And there's a couple other things, like Databricks is behind Spark, which is really hot right now. And there's a couple other things. Almost everyone, there's always a commercial company behind open source project, so that they can support training, support all that. And let's talk about data storage a little bit. So typically when we talk about data storage, there's the kind of two categories for now. One is DFS, distributed file system. And I just put one example here, HDFS, because for now it's most popular. How many people heard of Hadoop? Okay, so Hadoop is so popular these days. Probably back to 10 years ago, maybe. So they started that time. And go ahead.
What language does Hadoop use?
Hadoop itself, I believe, is that Java? Java, yeah. It's mainly Java. people building different things on top of Hadoop. So since we mentioned Hadoop, Hadoop typically means two things. One is Hadoop MapReduce. Another one is HDFS. MapReduce basically how you process the data. This one is how you save the data. Okay, because it's a distributed file system, so you don't need to care where exactly the data is stored. Because there's so much data you cannot store in one machine, right? And by having a file system, you don't need to know what piece of data to store where. Okay, that makes sense.
One question.
Okay.
If you don't care, actually the data safe, how do you deal with the backup and the storage?
Oh, yeah, good question. So it already has the redundancy built in. So one piece of data could be saved in multiple machines already. So
multiple copies?
yeah. But you don't need to care that details. You just make sure.
So the cloud and fallback systems could be.
Yeah. Redundancy, that's always good, right? Otherwise, once the machine shut down, then we lose some piece of data. That's not what we want. So another one is NoSQL. So the name is kind of misleading. Not only SQL. So they just try to differentiate with the relational database. Okay. So relational database typically is kind of tabular, right? Row columns, predefined, all that, predefined columns. And in this case, it's not. It's a schemaless. So basically, you don't need predefined schema ahead of time. So you have a flexibility to add a lot more fields as you want. Okay. Also, typically NoSQL is distributed. So kind of similar. To make sure that even one machine shut down, no big deal. So there are a couple types of NoSQL. Key value store, typically it's a name value pair. You really don't care about relations between those keys, names. Think about this one as a column. Okay. So if you don't really care about the relationship between this column and another column, then you can use the key value store. And document database. Because most of the time we do care. Also, they might have a hierarchical relationship between those fields. So that's one reason we are using document database. Does that make sense? Go ahead.
Wouldn't NoSQL will be flexible with the ERP systems, like using ERP or CRM? Because we have to have a relational data in order to pull tables together, in order to target specific information. With the NoSQL, what interface do you use to pull the data from?
That's a good question. Actually, you might still want to save your data in the existing format. We're not talking about getting rid of relational database.
So we still
We're
want
talking-
schema.
We're talking about if you have huge amount of data you want to handle, and if you have flexible columns you want to do, you can put it to NoSQL.
So you
So for the
actions.
for the existing content management system or CRM system, then it's okay. Leave it. That's what I think.
The database already.
Yeah. If you want, you can still switch. I mean, NoSQL, you can still define your columns.
So for
If you
enterprise will NoSQL scenario, like inside the company, we use it mostly.
you can still do that. Does that make sense? So another one is the column family storage. So instead of saving the whole document as the document database and save a name value pair and key value store, this one is kind of in the middle way. So you don't have a hierarchical relation between attributes. However, you do have a group information. So it's a group, not hierarchy. Okay, that makes sense? So each column family, think about it's a group. So you put all related columns into a same column family.
Can you do it?
So for example, transaction. Okay, any kind of transaction involved. Probably not the store transaction or something like that. But when you purchase something, then you can save the customer name, customer information into a one column family. That column family could contain customer name, customer address, all that, if you want to go that way. And another column family could be transaction information.
This kind of, we have the market table.
That's right. In relational world,
Yeah.
that's how you do it. Yeah.
Okay. Thanks.
But here, typically we save all those information together in NoSQL database, and you just append to it. And when you need it, you just grab data from each line. You don't need to touch other tables. That's one way to do it. So, because you can save lots of data. Oh, sorry. So another type of NoSQL is the graph database. Basically, if you have a database, you need to maintain relations, nodes and relations. Like, there are lots of examples, like friends, right?
You do that, I think the RT is used for the graph one, with the
So
graph database.
graph database, so for example,
You need RT.
archery. So think about a node is the person.
It's the algorithm.
Because of the time, let's ask a question after his talk. We can ask a question.
You have 5 minutes.
5 minutes. Okay. Sorry.
Doesn't make sense.
Okay, so think about like a person. They have a relationship with another person. As the friends of another person, right? So those are perfect example for graph database. So that you can find your friends very easily, your friends' friends very easily. Computation is a lot fast. So there are a couple examples for key value stores. So the first two top ones. Document database, like MongoDB, CouchDB, Docker one, column family, Cassandra, HBase. So HBase is based on HDFS system. And graph database, that's the interesting one. So Neo4j. So one thing I will mention is these two. Those two are pretty new. And the last one used to be Visual from Spark, but now they changed the name to Graphics. And I mentioned this one a little bit mainly because it's kind of pretty important. Real-time processing frameworks. So the first two are mainly doing streaming stuff. So that when data come in, you can process it right away. So those are so important, especially for fraud detection and things like that. You don't want to know after the fact. You want to know right away if it's possible. The next four of them actually is not really in the same category. Those are mainly for improving the performance on the data warehouse. Okay, so currently the standard one is the Hive, and everyone feels Hive is so slow, So they're trying to improve it. So one is from Cloudera or Impala, and yeah, another attempt from Horton Networks called Stinger, and Crystal is from Crystal. Drill, that's from Yahoo, I believe. Originally developed by Yahoo, then got accepted into Apache. Then the last two is mainly search engine, but you can also grab data out of it very quickly. And some of them, you can, so in Hive, for example, you can build table using your data underneath Elasticsearch, things like that. So let's mention machine learning packages a little bit. So Mahal, it used to be a Java package doing machine learning functions, algorithms. They have richest, based on my opinion, machine learning algorithms for them. And ML Lab, that's a new one giving play. It's from Spark. And they only have a very limited number of machine learning algorithms, but it's growing pretty fast. So that's why I would like to mention a little bit. And GraphLab, they changed the name to Dado. They changed the company names. Probably because they got 20 million funding from VC. And H2O, yeah, that's a pretty new one. It's pretty much Hadoop plus R. Okay. And they changed the company name from 0x Data to H2O to match the open source project. They got lots of funding as well. So PMML. How many people heard of PMML? Good. So predictive model. So basically that's an attempt by a DMG group, data mining group, trying to share models between different packages. For example, R can generate those, PMML. It's an XML format, basically. Okay, you specify what data can be in, out, what kind of algorithm you want to use, k-nearest, clustering, or whatever. So that's a good attempt. There's a couple things trying to support it. Cascading pattern. Cascading is the Java library for Hadoop MapReduce. And they're trying to do a lot of integration with Spark, anything you can think of. It's open source. So JPML, that's a Java API for PML. Hopefully this one will be good. Nice attempt. I'm not sure how long they can go though. So machine learning packages in R, probably not too much to mention about. Those are kind of standard one. Association rules. H2O I put in here because it's a pretty new play in that space. Machine learning packages in Python. And natural language processing. So do a lot of stuff in that space. Name entity recognition to be able to recognize people, address, phone number from sentences. You guys will. Sentiment analysis. So basically find out if the sentence is positive, negative, topic ordering, text summarization, question answering system. Those are good applications for that. And here's the trend. What I think is the trend. Okay. So Apache Spark is getting so popular, especially last year. Okay. Because it's really fast and it can handle both batch processing as well as the streaming. So both real time and off time. So that's kind of nice. In memory database, everyone playing their part getting popular, mainly because we need those kind of database to be able to grab data out quickly. So you can think about two-step process. If you need to take lots of time to process huge amount of data, but you need to put it somewhere so that runtime system can use that information. So that's important. Typically, it's done through optimizing SSD, solid state drive. So because it's a lot bigger than RAM, right? Regular memory. Another one is the advanced analytics, it's machine learning. So venture capitalist I talked to the other day, like 2 days ago, they're talking about this year is the year of machine learning, pretty much. I would imagine lots of money will pour into that space this year. So that's it. Any questions?
We probably have time for one quick question. If you have long questions, probably can grab it afterwards.
Okay.
Do you think in the future, big data will predict stock market or results?
That's
all
good
matters.
question. Everyone is trying to do it. They don't need to do anything else, right? That's where
What
the money
happened
is.
this year, oil price crashed. Nobody saw that before, right? I mean, everybody was surprised. I was wondering, where are all those big data guys? They're supposed to know what's going on.
That's a good question. I think we are using more and more data, trying to predict those kind of things, like social media. So you can read those things from social media and from news, right? Trying to do aggregate.
We will have, we will have another talk after the
Just real quick.
Okay.
How would companies like Overstock.com benefit from big data technology?
Oh yeah, we are using that already. We started like 4 years ago. So one thing I mentioned is a recommendation engine. We're using big data. So to predict what kind of thing a customer might be interested in, things like that. And we'll do a lot more like
From